problem 54 on page 508. So we're going to start with part A, which is finding E naught. And we can do that by looking at standard reduction potential table. So this is pretty straightforward. We've calculated E naught in a lot of other problems we've filmed. So we're going to just add up these two voltages, which you can get from the standard reduction potential table. Always remember that if something is here in the reactants and it's in the products side of the standard reduction potential table, you're going to have to change the sign of it so that it and flip the reaction so that it will match the reaction that you have. So this is pretty straightforward. So next we're going to write the Nernst equation for the cell. So the Nernst equation is E cell equals E naught minus RT times 1 over F. You can also have F on the bottom, but we just see it a lot of times in the top instead, over N, which is the number of moles of electrons, and then times ln(q). If we plug in what we know here, we got 0.265 before for the E naught, and this R, this will be the other R. It's not 0.0821, it's 8.315, so always remember that when we're working with electrochem, we're going to be using this R. And then temperature in kelvins, and then times 1 over Faraday's constant, which is 1 over 9.649 times 10 to the fourth. And then this is over 12, because that's the moles of electrons. If you were to look at this balanced redox equation, you would have 12 electrons, because as you can see, if you were to balance this, there would be 12 moles of electrons, and they would end up canceling out. So that's why we have it over 12. Okay, so now moving on to part C. So now we're actually going to solve for the Nernst equation and calculate what the E cell is. So we're going to write out what they've given us: 0.515 atmospheres, 0.993, 0.75 molarity, and then they give us a pH of 2.85. So for the pH, we're going to just do 10 to the negative 2.85 to get the concentration of the H+. It's going to give us 0.00141 molarity. And then we can plug in here. So we're going to plug in what we know into the Q expression. So we have the Nernst equation that we wrote in part B, and then we're just plugging in for Q right here. And always remember that the coefficients, that we're raising those to the power, and that it's products over reactants. And finally, we're going to get that, E cell equals 3.19 volts. That's all.